Welcome to this presentation on using a queue to simulate a account transactions. We're going to do something similar to one of your assignments where we're going to use a queue of messages to simulate potential banking transactions like deposits and withdrawals. We have a diagram over here that shows an account class, and each account is going to have a unique number, so an account number. The account is going to have a balance, and the account is going to have a transaction queue. And the transaction queue is going to contain a transaction message, which has a time associated with it, an account number that it's supposed to be sent to, the type of transaction, either deposit or withdrawal, and then the amount. The methods for the account class, in addition to initialization or a constructor, we want to be able to do a deposit, do a withdrawal, receive a transaction and store it in the queue, and then process a transaction from the queue. In the main function in our simulation, we're going to create a list of accounts, and then for so many iterations, 10, 20, however many you want to simulate, we're going to perform a random action. And we'll just pick a random number between 0 and 3 or 1 and 4. And if the random number is 1, then we're going to create a random deposit and then dispatch that transaction to the appropriate account. If the random action is 2, we're going to create a random withdrawal and dispatch that transaction to the account. And by dispatching it, we'll just be passing it to the account's receive transaction method. If the random action is 3, then we're going to process a transaction for a random account. So we're just going to pick an account out of the list at random and say process one transaction. And if the random action is 4, we're going to do nothing. It's just going to simulate idle time where nothing is happening. When we're finished the loop for a certain number of iterations, then we're just going to go through all the accounts and perform any remaining transactions in the transaction queue. So this simulates potentially some banking transactions and uses a queue to store them. And if you recall, the key property of a queue, one of the key characteristics of a queue is that the first item that goes in the queue is the first item that comes out. So we'll be processing the oldest transactions in the queue first, the ones that have been in there the longest, the ones that have waited the longest. So we will start with some of the code from the week 3 lab assignment that has a simple queue class. So I'm just going to make an account demo project. And I'll just copy the code from the simple queue class to this account demo project. And then just add this code to the solution. And we can go through and look at this. You see that the queue is created out of a static list of characters. So there is going to be an inherent limitation in that the queue can only have up to 10 transactions at a time. So if the number of random actions in our simulation is very large, there's the potential that this will overflow, and we may want to take some protective steps, some if statements to guarantee that doesn't happen. Another solution would be to replace this underlying container for the queue. Instead of a static array, we could use a dynamic array or a linked list. We won't worry too much about it now. For now, we'll keep it fairly simple. We will have to change the type of the queue. Instead of a character, it's going to be a queue of transaction messages, and we'll define what that is in just a minute. The typical methods for the queue, we can check to see if it's empty, we can enqueue, we can dequeue, we can get the value at the front. Pretty common. Main just kind of tests it, creates a queue of 10 characters, inserts some random characters, and prints them out. And we should be able to build and run this. So it's just displaying some random characters that have been placed in the queue. So let's go ahead and start to make our changes. The first change we want to do is define what a transaction message is. And so in order to do that, one of the things we're going to do is have a message time. I'm going to go ahead and put this in the queue header file, although in a larger project I might make it have its own message header file. So I'm going to start by creating a class called transaction message, and in here we're going to have an account number, a message time that's of this TM structure, we'll define that in a minute. Transaction type is either going to be a string, deposit, withdrawal, and then the amount of the transaction. In order to get access to certain things, we need some includes. So the time is for the TM type. The IO manip, we need to be able to print out numbers with 2 decimal places of accuracy, the set precision method. String, pretty obvious, we need string. And then I'm using another include here, you may or may not have seen, called string stream. And it's going to behave a little bit like cout, but it's going to allow us to easily convert formatted numeric values into a string. And we'll show you how that's done in just a minute. So the next step in the transaction message class is to create a constructor for it. And the compiler will sometimes complain if you have a parameterized constructor without a default constructor, so I'm going to make both in one. And the way I do that is by using default parameter values. So if a transaction message instance is created with no parameters, then these default values will be used. And so this particular constructor, sometimes they abbreviate it C2R in the documentation or the comments. This particular constructor is both a default constructor because it can be called without any parameters, or a parameterized constructor because we can call it with account number, transaction type, and amount. The time, we're going to get the local system time like this. We call time 0 and get this time t object, and then we have the message time, which is a TM structure, and TM has hours, minutes, seconds, and we can get the local time from this time variable into our message time. And later on we'll be able to extract the hours, minutes, seconds for the time the message was created. The account number gets assigned, the transaction type string gets assigned, and then the amount of the transaction gets assigned. So that takes care of the constructor. The next thing I'm going to do is to convert this transaction to a string so that we can print it out. So we'd like to see what's happening in our simulation, the steps that are taking place within our simulation. And one key part of that is to convert this transaction message into a string. And one of the key things we're going to use here is this string stream, which we get by including this stream header file. And what string stream allows us to do is to create a formatted string similar to how we would send information to cout or the console. So if you notice, this syntax here looks very similar to how we might print this out with cout, but instead of the output going to the console or cout, it's going to this string stream object. So it's being collected in a string that we can access with string.str. So what am I sending? I'm sending a message. I'm sending a string, creating a string that says at hour, minutes, second, account number had a transaction type, either deposit or withdrawal, in the amount of, and then this is for formatting. It says use fixed formatting with 2 decimal places, amount. So this is creating a formatted string stream, which we then return as a string type. So this allows me to convert the transaction message into a string that I can print out for viewing what's going on in the simulation. So now the next step is to modify the queue. In our diagram, the queue is a queue of transaction or transaction messages. In our code, the queue is a queue of character. So all I really need to do is to change it so that it is a queue of transaction messages. And when we enqueue, we're enqueuing a transaction message, and when we're getting the front of the queue, we're removing or copying from the front of the queue a transaction message. And then we need to make some of these same changes in the implementation file queue.cpp. We need to find the enqueue and change that to a transaction message. And maybe we call it message, make it clear. And when we remove from the front, we're removing and again, we're not really removing, we are copying the transaction message from the front of the list. If we actually want to remove, we would do this dequeue to actually remove. So it's showing some error message. Let's go ahead and compile this module and see if we can fix what these error messages are. So it doesn't know what transaction message is because I was playing around with this before and I changed the path for the include, so I think that might fix it. Okay, so this build's okay. So that takes care of the queue and the queue and the transaction message. So I have a queue. I'm able to create a queue of messages. Now I'm ready to build this account class. And I will put that in a separate header file just to show you how you can do it. So we're going to add a new item, header file, account.h. Make sure it's in the same folder as the rest of our project. And just for now, I'll make everything public to keep it simple. And the data members in the account are going to be a number, a balance, and a transaction queue. So we have an account number, which will be just an integer, a balance, and a transaction queue. And so in order to get access to the transaction queue, we have to include that header file. We'll create a couple of simple constructors. We could combine them with default parameter values like we've done before. And here's a couple of constructors. One default constructor just sets the balance to 0, and one parameterized constructor that gives us an account number, which we'll use later on when we create the accounts. We'll give them numbers. The deposit and withdrawal are pretty straightforward. We just pass in an amount and update the balance appropriately. So that's pretty straightforward. To receive a transaction is also really straightforward. We just take a transaction message and enqueue it or put it into the transaction queue. To process a transaction is a little bit more complex, but not too bad. To process a transaction, we're first going to ask if the transaction queue is not empty. If the transaction queue is empty, we can't do anything. There's nothing to process, and so we print out a message that says no transaction for account number, whatever. If the transaction queue is not empty, we're going to get the first one and then actually remove it. So we get a copy of the first one in the list and then remove it. We check to see if it's a deposit, and if so, we deposit it. We check to see if it's a withdrawal, and if so, we withdraw. And then we just print out some message that says what happened. We processed a particular transaction. We convert the transaction to a string, so that's calling this transaction to string method, so we'll get the time, account number, amount, and so on. We'll see what the transaction was, and we'll print out account number has a particular balance. We'll display the balance after the transaction occurred. We've got some red lines here under C out, so I think that means we need another include. Stream, as well as for the formatting we need the IO manip to do the formatting, and then using namespace standard. In this particular case, instead of creating a separate account.h and account.cpp, I've put all the code within the header file. It makes things a little bit simpler for demonstration purposes. In a real project, I might separate and put the actual implementation code in a separate CPP file. And over the long term, it might make for larger projects, might make for some faster compilation times. But for this simple demo, it might be a little simpler a little bit easier to demonstrate. We've put it all together. So that's the account class. So now let's start modifying main. And again, I've got a different path. It's all in the same folder, so that just use a relative path there. And we will also need to include the account class, I believe. So in main, one of the first things we're going to do is to create some accounts. So I'm starting out with pretty much an empty main, just removed almost all of it, and then I've got a few account numbers that I just made up. And then I'm going to create a list of accounts, and for each number in this account list, so there's 3 of them, I'm going to push back a new account that's constructed or initialized with this particular account number. And in order to use this STL vector, I have to include vector. Okay, so I've got 3 accounts, 3 numbers that I just made up, and the reason I have them in a separate list will become clearer in just a minute, it's much easier to get a random account number if you have it in a list like this. And that'll be clearer in just a minute. And we have to know what the account numbers are because the transactions are going to be dispatched or routed to those particular account numbers. All right, so then the next step is to go through a certain number of iterations simulating different steps that might occur. Maybe we'll do 10 steps. And we're going to create a random number for a particular action. And in our case, we're going to do 4 possible different actions in our simulation. We're going to create a random deposit, create a random withdrawal, process a transaction from a random account, or do nothing. It's just nothing's happening at a particular time. Okay, so then I'm going to say if, and in this case, because I'm doing rand mod 4, my action numbers are not going to be 1 to 4, they're going to be 0 to 3. When you do a mod of 4, the possible remainders are 0 to 3. So action 0 is going to be a deposit. Action 1 is going to be a withdrawal. So action 1 is a withdrawal. Action 2 is going to be process a transaction from a random account. And then action 3 is system idle time. Nothing's going to happen. So if we're doing system idle time, I'll just print that out, say we're not doing anything. So we know something's going on, it's just not doing a transaction. For the deposit, we're going to get a random account number and a random amount. And to get a random account number, I can create a random index in the range of 0 to the size of the account number list. My account number list has a size of 3 things, so I'll be getting a random number mod by 3, so I will get an index of either 0, 1, or 2, and that will get me one of these account numbers. So it's one of these 3 account numbers. We don't know which one because the index will be a random number between, in the range 0, 1, and 2. The amount, I'm going to get a random amount in the range of 0 to 1,000. So that'll be the random amount of the deposit. The next part then is to actually create the transaction message. So we're going to construct one and store it in this transaction message variable. We're using the random account number. This is a deposit type of transaction in a particular amount, random amount. And then I'm going to create a function to dispatch this message to the particular account. So I'm going to pass in the account list, and I'm going to pass in the transaction message to this function called dispatch message. And I haven't written that yet, so let's start that. The account list is a vector of account. And the transaction message is a transaction message. Sometimes I like to write my parameter lists like this with one parameter on each line. Now here's something that we need to be careful of. The account list in main has the actual data for the accounts and has a balance and transaction queues. If I call dispatch message and pass in account list here, it's going to be passed in by value. And when you pass something in by value, you make a copy of it. So what that means is I would have a separate list of accounts here in dispatch message that would be different from this list of accounts. So when I sent the message to the account, it wouldn't change the one in main, it would only be changing the copy of the one here in dispatch message. So we know in C and C++ that the default parameter passing mechanism is by value, which makes a copy. And if we make a copy of the account list, we won't be changing the one in main. And we want to change what's in the transaction queue for the account and potentially the balances of the account. So we need to make sure that we pass in this account list by reference because we want to change it. We want to add the transaction message to the account. The transaction message, we could pass it in by value. It's okay to make a copy of that. That shouldn't be an issue. But it's a little bit less efficient. So what we often do is pass in a constant reference, so that, meaning we're not trying to change it, but we want to pass it by reference for performance reasons, so we don't make a copy of the transaction. So in the dispatch message function, we need to do a search and figure out which account this message is for. There's a couple ways to do that. One is to do a range-based for loop. Where for each account in the account list, if the account number has the same number as the transaction message account number, then we found the account which the transaction message is for. So that we're doing a search here. Notice that we're also creating this account loop variable as an auto reference. So the auto keyword means it'll automatically figure out what data type it should be, which is going to be account, as that's what kind of thing is in the list. The reference meaning we don't want a copy of the account, and that's for the same reason that we passed in the account list by reference. If we make a copy of the account, if it's a value, we get a copy of the account, it won't be changing the transaction queue that's in the account list. It'll only be changing the transaction queue that's in the copy. So you need to be a little bit careful here when we're using a range-based for loop, that we, in this case, we want to change the account by adding a message to its transaction queue, so we want to make sure we're using a reference to the account. So if we find the proper account, then we just want to have the account receive the transaction and print out a message of what happened. So we loop through all the accounts by reference, find account that matches the number, have the account receive that transaction message, which means just put that message in its transaction queue, and this printout that says, okay, a deposit or withdrawal was dispatched to account number, whatever the number was. And that will suffice to dispatch our message. So I think we're pretty good on deposit. Now for withdrawal, it's a similar step. Maybe I'll use a slightly different amount. Random amounts in the range of 0 to 500, but the random account number part's the same. We just need to change the type from deposit to withdrawal or whatever string we used in account here. We just have to make sure that the deposit strings match up so they can be found appropriately. And then again, we're going to dispatch that withdrawal message. And then the other action that we haven't written the code for is to process a transaction from a random account. So in order to do that, it's a little bit similar to dispatching, where we get another random account number again, loop through the account list to find the appropriate account, and then once we found the account, instead of dispatching or sending the message, we're just calling its function process next transaction. So if that account has a transaction in its transaction queue, it'll take one out and process it. It'll either do a deposit or do a withdrawal. And we can break out of the loop because we're just going to do one. We'll just be doing one transaction for each iteration of our simulation. And that's enough to make our simulation run. It's just that when we're finished, it's likely there are going to be some transactions in the account's transaction queues that haven't been processed. So at the end of our simulation loop, we're going to have 10 turns or 10 rounds for simulation action. At the end of our loop, we may want to process any remaining transactions in the accounts. And so we can loop through each account, see if their transaction queue is not empty. So again, loop through each account by reference, ask if the account's transaction queue is not empty, and while that's not empty, process the next transaction. And this process next transaction will print out a message, so we can print out a return, give us some blank lines, and I guess at the end of each iteration of this loop we can print out a return to space out the output. So if we try to build this, succeeded okay. We have a warning about converting an int to a float here when we're creating these random amounts. That's not that big a deal. Let's put a breakpoint in here and watch what happens. So I'm going to put a breakpoint right here on determining the action that we're performing. And if we run in the debugger, start debugging, we don't have anything on our output just yet. We'll step through the code. So I'm going to use step over F10. I'm going to use the F10 key to step over. So my action has a value of 1, so this first action is going to be a withdrawal. So that's actually going to make one of the accounts go negative because the accounts are initialized with a balance of 0. So right off the bat we're overdrawn. So we create this transaction message that has an account number, a time, hour, minute, second associated with it. It's a withdrawal and the amount of 334, and we dispatch it to the account list. And that's the end of that step of the simulation, and it says here that a withdrawal was dispatched to account 1274. We'll keep going and get another action, and now our action is 0, so we're going to do a deposit to account number 1274, and that amount is $724. So if we process both those transactions, that account will be positive again, I guess. The next action is action 2. So that's going to process a transaction from a random account, and the account number is 3433, which shouldn't have any transactions, so we get a message, no transactions to process for the account number 3433. So we'll keep going. The next action is processing a transaction and 1274, so we should process a So we found the account, we processed the transaction, and it says at 15:37:26, so that's 3:37 p.m. account number 1274 had a withdrawal in the amount of 334, and because the balance started out at 0, that takes us negative. We'll keep going in our simulation. And the next action to do is a deposit. Oh, sorry, no, one is a withdrawal, and that withdrawal is going to be from 1274. Yep, 1274 again. So another deposit, 281. Dispatch it. So this account 1274 is getting most of the transactions so far in the beginning of our simulation. We'll do another action, action 3, which is system idle time. So nothing, we just simulated nothing happened at that particular interval or period of time. Here's another withdrawal from account 1274 again. That's a real popular account, I guess. Dispatch it. Action 2. So now we're going to process another transaction. We have to find the account first. And unfortunately, we picked an account that doesn't have any transactions in it. 3433 was the random account, and there's no transactions to process. So we'll do this a couple more times. Let's see. Action 0, we're going to do a deposit for 3433. Action 2, we're going to, okay, so we just put in a deposit for 3433, and now we're going to process a transaction from 3433, so that should be that deposit. So if we find it, we process it. So transaction processed at 3:40 p.m. for account 3433, a deposit in the amount of 604. So now the balance went from 0 to 604. So we can just remove the breakpoint and continue running this simulation. Continue, and we see the rest of the transactions occur. So could have put steps in the simulation, but towards the end we just processed the remaining transactions. And so 3433 had a deposit. So we saw that one already. 1274 had a deposit. 1274 had a withdrawal. So the balance went down. 1274 had another withdrawal, so the balance ended up being negative for 1274. So in this presentation, we've seen how we can use a queue to simulate storing a list of steps or a list of action or messages. In this case, they were transaction messages. And then at random times, we either made a deposit message or a withdrawal message to a random account, or we decided to process one of the transactions in the account's transaction list. So we took it out of the queue and actually did the deposit or did the withdrawal. So this is a demonstration of how we can use a queue of messages or transactions. And it's similar to an assignment that you have to work on in the class. So please let me know if you have any questions about this demonstration.